Hello everyone. So here we are doing lab 3 based on real-time physics integrated into the IOLab software developed in University of Oregon, Portland State University. So let us start by, I've already opened the software. Let us start by putting the dongle into the USB port of your computer. Okay. When I put it into the computer, this thing will turn on. You can see that, okay. Okay, you see it has on appeared, yeah. Then let us turn on our IOLab device also so that it will be paired. Like you can see the blink here, yeah, it's blinked. It's blinking, the light is here. And okay, we are going to do lab 3. So let's go to our regular lesson list. Okay, lab 3. So this is disturbing me. I can put it aside for now. Lab 3. Okay. So lab 3 is about changing motion. Yeah, changing motion. We did position time graph, velocity time graph, relation between them in lab 2. So we'll be seeing more of acceleration this time. Actually, their acceleration, their magnitude, their direction, how it is related with the velocity graph. So we'll be looking onto those things. So you may write your name. If you are working in a group, you may write your group, all of your name, but we are working individually here. So you can write your name, save and go next, okay. Okay, after we wrote our name in slide 1, then we click save and go next. It takes us to slide 2, okay. So we are going to do velocity and acceleration graphs when you are speeding up. Speeding up means increasing the speed as the time goes on. So we have to predict based on like what will happen if we speed up as the time goes on, yeah. So it's a ramp is here. So we are going to move in positive y direction. Again, to remind you, since like I have been reminding from the beginning lab, in the IOLab device, okay, IOLab device, if you see the direction of positive y-axis, yeah, this is from single wheel towards the double wheel, but that is not the actual direction of positive y-axis return for the lab here in the IOLab system. Okay, so actual positive y-axis, like moving to our right from the origin, or moving to positive y-axis will be from double wheel towards single wheel. So you have to consider positive y-axis to be going down towards the single wheel from here towards the down. Okay, not the ones on here in the actual device. So it will be going down from here, double wheel towards the single wheel. It's positive y-axis. Okay, so if we see here. So we are speeding up. So now we have to do a prediction which of the following graphs would represent position versus time as the IOLab rolls down the ramps on speeding up at a steady rate. So we have already done when we move in positive direction, if the speed was steady, if the speed was constant, there will be a line with positive, like positive slope in, there will be a line with positive slope, yeah, in the in positive direction while moving in positive direction. Now in this case the speed is not steady, so it is going to increase. So based on that we have to make a prediction. I have already given the hint that there will be a positive slope if while moving in positive direction, speeding up, yeah. So there will be a positive slope. If it is speeding up, then that slope has to be changing. So if we are here increasing the speed, that slope has to constantly change, and it has still to be positive, okay, in the part of time. So go ahead and make a prediction for that. Okay, after making the prediction in slide 2, do not forget to click on save and go next. Okay, in the next one, so they want us to predict velocity versus the time. Speeding up means the velocity will be changing constantly, yeah, like increasing speeding up means it will be increasing constantly. So based on that, so the slope of the change, like slope will be a constant thing for velocity versus the time. There will be a linear graph with constant slope, okay, positive slope if it is increasing up. So based on what I have said, you may go ahead and predict the velocity is increasing at constant rate. So the slope slope for velocity, and time would be positive, okay, and it would be increasing at constant rate. Okay, go ahead. Velocity would be increasing at constant rate. So based on that, you can go ahead and predict for this one also. After predicting, make sure to go do 7, go and 7, go next. Okay, so try to make a good prediction. The result we will be seeing at while doing the actual experiment. Okay, in slide 4, we are going to predict the acceleration now. So we'll remember we are going to move in positive direction, and it is speeding up. Okay, means velocity is changing at constant rate. So rate of change of velocity is acceleration. So it is speeding up. Velocity is increasing at constant rate. Okay, so based on that, so I've already given. So you may go ahead and predict the acceleration. Okay, velocity is increasing at constant rates, and the rate of change of velocity is acceleration. Velocity is changing in positive direction. So go ahead, make a prediction for acceleration versus time also. Okay, and then click on save and go next after you make the prediction. Okay, after that they have told us what we need to do the experiment here. So we need okay, we will all obviously we need our IOLab. Okay, we we need our IOLab with the force sensor in, and okay, so smooth ramp at least 0.5 meter long. So I use this board. Okay, and inclined at least 30 degrees. So you may increase, you may see the angle, you may measure the angle here. Okay, or if I want to increase, I can slide it down and increase the angle also to make it more than 30 degree. Okay, so around, okay, that should be fine. Book or other objects, you can elevate the ramp, yeah, which I did already. Okay, and then protector, so with which you can measure the angle. Okay, now time to do the experiment. So first thing, okay, so if you see here, okay, your remote is like not paired, yeah. So if you remain inactive for some time, the remote will go off by itself. So to save the battery, that's a good thing. Okay, so you may power on again. Okay, power on again, so it will be paired again. So after that, so we are going to move in positive y direction. Okay, so the graph, you may see the graph. Put it somewhere around here. That's so that we can have put in. Okay. Do not forget to click save and go next. Okay. I think I need a record button here. So here would be okay. Okay. After that, they want we have to make the ramp around 20 degrees Celsius. Okay, and they want us to move in positive y degree. We are moving in positive y direction, speeding up. So make sure this force sensor where you have this points toward positive y, like where you have the force sensor, this is pointing towards double wheel to single wheel. Yeah, that will be positive y axis. So you can go ahead, you can click on top for the IOLab. Okay, you can go to put on the top. So and then you may go ahead, click on record button. Okay, and then you can leave. Make sure to catch the IOLab when it is down. Okay, so you may repeat the experiment if you are not satisfied. Okay, you may repeat the experiment. You can click add run, repeat the experiment. You may remove the run you don't want to see. Okay, but I think I'm satisfied with what I have done. So okay, we did the experiment. Now see your region of interest. Okay, region of interest is when the IOLab was trading up or it was moving. Yeah, so basically this will be the one. And okay, so let me just select, we can use our zoom tool. Yeah, so let me do it from, this was all rest. Yeah, I was not moving, I was just holding the IOLab. This was the point when the IOLab was moving this region. So let's do it from 1 second to around 3 seconds. Okay, so this will be good. Okay, so you may go ahead, click save and go next. Okay, now they want you to do the analysis part. So what the moment you release the IOLab, so when it is at rest, it is not released. Yeah, so the time it is, the position starts to go like change from 0 to something. So you have to write that time here. Okay, the moment you stop the IOLab, so you'll write the time when the position becomes constant. Yeah, so right around here. Okay, or the velocity becomes 0, like when you stop it, catch it, the velocity like goes down, it starts to go down. Yeah, does the position time agree with your prediction? So based on your prediction, so and your graph, write your answer. For everyone, answer will be different. Okay, so you may go ahead and write your answer. Okay, just to clarify, okay, so while writing, the moment you stop the IOLab, the point will be like when you stopped it here, okay, starts to go down to zero. Like I have seen people writing right around here, okay, that's not the point. The point is when you just stop it, okay, or it can be this point also, okay, so in the acceleration turns to a never, when you stop it, it turns to go towards zero, okay. You might have a straight line here also. You might do a next run if you want, okay, so it will go like this. So the point is right here when it goes like just turn around when you start, okay. And for the moment you release is like around when it starts to go from zero, or you can start from this point also, yeah. This point means same thing. Let me zoom in the recording for clear view, okay. Then you can select which side you want to zoom also. Okay, I wanted to show you next thing. So if you may do auto scale also, okay. You can click here and then do like write your values, maximum value, minimum value, and do the auto scale like based on your values in the graph. Like we need from 2 to -2, 3 to -3, yeah, 3 to -3. So I'll just keep it 3 to -3 here, and then we can auto scale so that we can see the range of our graph. Okay, 3 to -3. Okay, so it is like asking you to compare the position time graph with lab one, introduction to motion. Okay, so when we did that time, the speed was constant. We were moving with the steady speed, yeah. But this time we're speeding up, so you might not be clear. That's why I am just trying to. So you might think it as the same, but you can see it is not more. It is kind of more curve. Okay, like this, it is not linear as it was in. It was a straight line with constant slope in during lab one, introduction to motion. But in this case, it is kind of not linear. Okay, the very speed it is increasing with the time. So if you can see it here, okay, it is speeding up. That's what it means. Okay, so it is not like exactly linear with constant slope as it was in lab one. Okay, after we compared the position time graph, they want us to do the compare the velocity time graph also. Okay, so and the reason of interest is like whether the IOLab is speeding up. Okay, this is the part of reason. So that's what we'll see for the while answering the thing. So what feature of your velocity graph indicates that motion of the IOLab was in positive direction. Okay, so we did it in while doing lab 2 also, if you remember, like introduction of motion. Okay, so in that lab also we did that one. What feature of velocity of graph indicate that our lab was speeding up? So from what we can relate, how does the graph of motion with the constant velocity in as in lab 1 differ? So here it said lab 1, but yeah, we did in lab 2, I think, introduction to motion, yeah, for this IOLab integrated system. So you can compare with that one. So what was there and what is here? In lab 2 we are moving steady with the constant velocity, yeah, constant speed, so it was kind of a straight line. But in this case you can see it's linear. In that case velocity itself was linear, but now we have a velocity that is changing with constant slope, constant rate, yeah, so that's why it has a constant slope. You can go ahead and answer these questions, okay, based on your predictions. You can look at your predictions, answer these questions, and after you fill this, click save and go next. After the velocity time graph, we'll make prediction for acceleration time graph. Okay, the main idea behind this video was, so what kind of graph you will expect. Okay, but the analysis part, you will be doing it more. Then I'll not be writing each answer for you, because you have to learn while doing the graph. I'm just making sure you do not get the wrong graph. Okay, based on the direction, it's like analysis. So you can see that the acceleration time graph agree with your prediction. Go ahead, go answer that one. Okay, so you can see the acceleration, see your region of interest. Okay, the where the IOLab was moving, whether it's positive or negative, you can see it here. That's constant or not. During the time IOLab was speeding up, the acceleration was positive or negative, you can see it here. Okay, so how does it speeding up while moving in the position result in the sign of the acceleration? So you may go ahead and answer it, and after that click on save and go next. Okay, Okay, next slide, slide 10. So you will give answers based on the graphs. Yeah, how does the velocity vary in time? So this is the rate of change of velocity. Yeah, so is it constant or something? How is it varying with time? It's linear with constant slope. So does it increase at a steady rate or some other way? So you can, this is the rate of change of velocity. Acceleration is rate of change of velocity. Yeah, so is it constant or no? So you can answer in that way. How does the acceleration varying in time as IOLab speeds up? So how is it varying as IOLab speeds up? Is that what you expected based on the velocity graph? So rate of change is given by the slope. Yeah, so is the slope constant? So if it is linear, then the slope has to be a constant thing. Yeah, if it is changing linearly. So the rate of change of velocity gives acceleration. So based on this one, this has to be constant. So is this what I expected? Go ahead, based on your graphs you may answer it. Okay, this is rate of change of velocity. It is increasing with a constant slope, means that it should have constant acceleration. And do you see that in here in your region of interest? Go ahead, answer your question and answers here. Okay, and make sure you answer all and then click on save and go next. Okay. Okay, in slide and okay, while writing the answers in previous slides, okay, so make sure which is the reason you have to get then do the analysis from. Okay, so this the reason is where the IOLab is speeding up, means the IOLab is moving. Yeah, so the reason while making the analysis is see this part only for this graph. Okay, particularly in other graphs it might be different, like the graph might shift other sides. Okay, like if we start to move from here, graph would be like this. So the reason is the reason where the IOLab was moving, speeding up. Okay, so that's the only reason of interest while doing the analysis. Because if we see here the velocity is zero, yeah, we cannot do analysis based on that. While speeding up, we are trying to see the rate of change of velocity is constant. Yeah, it is constantly increasing. So be careful about those kinds of things. Okay, after we have done those things, in slide 11 they want us to represent the velocities at different time in terms of arrow. Okay, so you have to use these symbols. Okay, use the symbols to represent the velocity vector at 4 different times and label them 1 2 3 4. Be sure to indicate the magnitude of velocity as each time with the length of the vector. For example, this and this would represent small and larger velocity. Okay, as it speeds up. So you may take it as it already has some velocity, or if you say it doesn't have velocity, you have to start with a dot. Yeah, so you may do that also, but let's say it already has a velocity. So as it is speeding up, so okay, I think t4 is 3 seconds. Okay, let me just, okay, so they want us to label as 1 2 3 4. So you may go ahead, write 1 as first for the 1 is for this one. Okay, so you have to as we did in last lab, so we can represent vector with arrows, so representing velocity with arrows. Okay, so if you point toward right direction, velocity will be positive. Yeah, pointing towards left direction, velocity will be negative. Okay, if we point towards left, so if we see here, so let's say this is point 0, you can say it as point 0 point t2 equals 1 second, 2 3 equals 4, like this is the changing time. Yeah, so what is happening, velocity, we are speeding up, so velocity is increasing. So if you write it, that's is velocity positive or negative, is velocity positive or negative, is velocity positive or negative. If it is positive, use the right arrow. Okay, and magnitude is determined by the length of the arrow you draw. So while making the arrow, so we have whether we have to make a small arrow or big arrow. So right here the velocity is small. Yeah, so the small arrow will do the job. So if we make it here, you have to make a longer arrow since velocity is higher. Velocity is higher. So same here, as it is speeding up, so decide whether it's positive or negative. Based on that, make your direction of the arrow. So whether you have to draw like this or like that. Okay, and for the magnitude, if it has higher magnitude, then use longer arrow here. Okay, draw longer arrow here. So you may go ahead, draw it here, and then click save and go next after you do that one. Okay, and then you can move to the next one. Okay, in the next slide, slide 12, so they are asking how will we see, like, find delta v, yeah, change in changing the velocity vector, you see delta v, you see. So it's kind of acceleration if it is for any time. Yeah. So if we take 1 second, that's going to be acceleration, kind of determining the sign of the acceleration also. Okay. So choose from the choices below. How would you find vector representing the change in delta v between times t3 and t4? Okay. So first thing, so this is a speeding up case. Yeah, we did it for speeding up, which y direction it is speeding up. Decide whether they are positive or negative. So we are moving in positive. This is our velocity graph. Yeah. So at t3 also is positive. At t2 also is positive. Okay. Now t4 and t3, they both are positive. Yeah. So we need to see the vector that is both positive. So these are both positive. This one positive, one negative. So we can take that one out. So v4 positive, v3 also positive. Okay. T3 and T4, and remember that change. So after that, if we see here, okay, so we after that we are seeing rate of change. So we'll be doing positive minus V3. Okay, so minus V3. So if you see V4 minus V3, we have to do to take the delta V, yeah, V4 minus V3. So it's going to be V4, and minus V3 means if it was V3 only, that would have been positive, yeah. So but yeah, next thing, V4 has to be longer than V3. You see, V4 is sort of, in this one it is longer, but we are doing minus V3, yeah. So that is giving rate of change. So V4 minus V3, and the change is, so if this, the positive side is longer, positive one is longer than the negative one, yeah. So that should be slightly towards the positive, and that will be giving the delta v. So you have to we have to be careful with that. So we are getting the change. Delta v means the one at t4, which is v4, minus one at t3, which is minus v3. Okay, v4 minus v3, minus this, the direction of v3 is reversed by this minus sign. Okay, v3 itself is positive, v3 will be towards that side, but making minus will reverse the direction, and the change is given by this thing. Okay, you may go ahead, click 7, go next, and that's the acceleration for sure. Okay, based on the direction of the spectra and the direction of the positive y-axis, what is the sign of the acceleration? Positive, negative, or zero? So you have to, we already said that, yeah, the direction of this vector. So rate of change of velocity. So we got the change of velocity when you had the pen of change, was it positive, negative, or you can see it here. When the change, while change of the velocity, was it positive, rate of change of velocity was positive, negative, or zero? So you may go ahead and answer that in slide 12. Okay, I think slide 13. Okay, so you may go ahead and answer that. So does this agree with your prediction? And then you can answer it, and 7, go next. Okay. Okay, now we want to do like compare while what happens when we speed up more, means so we'll increase the rate of change of the speed now. Okay, and see what happens. For that we can increase the angle of, okay, because I can increase the angle of the ramp. Okay, let me show this one. Okay, this ramp, so we can just add something in here. You may add a textbook also, so that will increase the ramp, means the speed will be increasing. Yeah, and then you can see the IOLab is now disconnected, so you may have to turn it on since we have been inactive for some time. Okay, turn it on. So direction has still, it should be still same. Yeah, so positive direction has to be downwards. Okay, double wheel towards the single wheel is the positive direction. So we'll follow the same thing again, and then we'll click record, and then we'll leave it as we did. Okay, I think let me put it here. So you can predict first. Okay, so what will happen to the acceleration, what will happen to the velocity time graph, all of the things. Okay, and then let's keep it here. Now you can click on record. Okay, and then like, it is better if you can do it at similar times here so that you can compare. Actually, it happened for me. If you are not satisfied, you may do it again. You can keep it here. Okay, we can add run. Okay, and then I can leave it. Okay, make sure to catch. Oh, I didn't record. Okay, sorry about that. So you can record it here and let me read it. Okay, so make sure to catch it. So if you are satisfied, it's okay. You can do it again, your choice. Okay, you can remove it now also, but do not remove the first one. It was from the previous case. Okay, so be careful of that also. You can add on. You can record it. I'm just trying to see if I can get the one in the similar time so that it will be easy to compare, nothing more. Okay, so if I remove this one, That was not the first one, so let me keep the last one and see. Okay, I think it works for me. Yeah, it was kind of similar. Like time does not have to be similar to compare, but it will be good if we have in similar time. Okay, so this was with the higher, it's speeding up more. So in this one is the rate of change of speed, velocity was less. The rate of change of velocity is high. Slope is higher. Yeah. So, but it looks kind of same. Okay, if you want, you can do it again. So, but acceleration is a little bit higher. Yeah, not more actually. Okay, let me see if I. But you can increase the slope if you want. Okay, if you need. Let's see if that will give a little bit. It's around 30 degrees, but it has told already. Okay, so I can add on. You may do your own as you like. Okay, I recorded it. So kind of wave, yeah. So that's, oh, see, it auto scaled. So let me remove the last one. Actually, the first one was enough. I'm just doing it. Okay. Okay. That's also okay. It's not that bad. Eh? So let's see which one we want to keep. Anyone is okay. I think the third one is also okay. So let me remove this. Okay, so do this one. Okay, so while comparing which your what is your region of interest, like now the region of interest, you can compare this region. This was when I moved faster. Okay, so if we you can already see how it is speeding up more, means the velocity rate is like changing quickly than the previous one. Yeah, so you see acceleration is a little bit higher already, so the position it it moves quickly. Yeah, obviously. So based on those, go ahead, write your answers here, analyze the graph. As I said, so don't analyze it here. Okay, we don't know that this is here. We don't analyze it here. We have not moved. So see your region of interest also while doing the analysis. Okay, and then you can do the analysis. Okay, now we'll be slowing down and speeding up. So we'll in the inclined ramp and slowing down. You will position the ramp so that allows me moving in the positive direction while slowing down. So we have to move IOLab in such a way that while slowing down, it will be moving in a positive direction. Okay. Okay, let's go clip and slip. Okay, so I think it's time to make a prediction. Okay. Okay, so the ramp will be set up like this. So you can see this is a positive direction here. So you again in the IOLab. So this force sensor is in the direction where the positive, this force sensor, this sorry, I volt is where the positive direction of the like y IOLab is. So we consider from double wheel towards the single wheel is a positive direction. Yeah? So this is positive direction for now. Moving toward the right or positive direction. Okay. So if you see in the figure here, so this is the positive direction. So moving, this is the positive direction plus y direction, double wheel towards the single wheel. Okay, be careful of that. Don't follow the actual direction shown in the device, which is shown as single wheel towards the double wheel. The direction has to be towards this eyeball. Okay, you can make it 20 degrees. So and then they want us to I think push it from here, yeah, so that it will if we give a push, it will have some speed in the beginning, then it will slow down as it goes here, and then it can return back in the beginning. Okay, so we are just talking about slowing down now. In this act we will look at a belt moving in the positive direction and slowing down. The alarm and ramp should be set up as so when you give the alarm a quick push at the ramp, it will slow down after it is released. Okay, you will stop it at the top before it rolls back. We will not let it speed back. Okay, come back. We'll just stop it at the top when it is completely slows down. Okay, so if you the ramp and release it, it will the acceleration is positive, negative, or zero after it. So we have to decide. They want us to predict the acceleration. Acceleration is rate of change of velocity. So if the velocity is decreasing, yeah, so in positive direction velocity is decreasing, so final velocity minus initial velocity, so divide by the time. So based on that, you may go ahead and make the prediction. If you are moving in positive direction, as we already know, velocity is positive, yeah, it will have positive sign moving in positive direction, but the velocity is decreasing with the time. So later so at for the time velocity is less. Okay, so something is small, positive is small, minus something positive big is going to give you negative or positive sign. Based on that, you can go ahead and predict the sign of the acceleration. Okay, in the next slide they want us to predict the velocity time graph. Yeah, so as I have already indicated, if you are moving in positive direction, sign of the velocity will be positive. Moving in negative direction, sign of the velocity will be negative. Okay, so what is happening to the velocity? Like, is it increasing or decreasing? Slowing down means velocity has to decrease. Okay, so you might like it will sometime it will be confused seeing the graph. Okay, so but the key concept, moving in positive direction will need to have positive velocity, positive sign of the velocity. Okay, so see where the value of the, so you can take this out because you can see the value of the velocities are negative. Yeah, but we are moving in positive direction only for now because we will be slowing down towards the positive direction. So see based on that, and it has to be slowing down, so we need for speeding up constantly, that's time love at constant rate. Okay, and slowing down, so based on that, go ahead, make your prediction for velocity versus time also. Okay, and click, don't forget to click save and go next. So after you did velocity versus time graph, so based on now the rate of change of velocity is acceleration again. Yeah, so based on that, decide whether the acceleration has to be positive or negative first. Okay, and then as as a hint, we already said while speeding up or slowing down, the rate is constant. Yeah, the rate of change is constant, so it has to be a constant value. So decide whether it's positive or negative. Okay, so go ahead, because you can see your prediction of velocity versus time graph, and then based on that, rate of change of velocity is acceleration. Okay, then delta v, we'll keep the sign. Delta v means like v at father time to feed v at beginning time. Okay, we use the sign, so you can do this, do the math and get the, like, do the analysis and get the sign of the acceleration. Okay, so predict your acceleration time graph also. Okay, now time to do the real experiment. So because of the inactivity, IOLab has again gone, has turned off. Yeah, so we have to turn it back again. Okay, and then we have acceleration and velocity now. Okay, so these answers, we can answer those. So remember, we are slowing down in positive direction. Okay, so the motion, the IOLab will be moving, the direction IOLab will be moving should be a positive direction. So if I give a push from here, gravity is going to pull it down. Yes, that's why it has to slow. So you can start from here, okay, in the bottom. So make sure your positive y direction is this side, means double wheel towards the single wheel is this side. Your this eyeball has to be towards up. Okay, so that is our positive y axis, that's negative. So what you can do, they want us to record. Yeah, give a quick push and release it and stop it near the top of the ramp. So what you can do, so you can release, record it, you can give a next switch and we can stop it. Okay, yeah, this is also okay if you want, or you may add run as we have already said. Okay, add run. Okay, and then let me straight fast possible record. Okay, and then I can go, it makes sure to stop. Okay, if you don't stop, there will be some like that. Okay, let me try the next one also. Still a little bit red. Okay, let me do it for the last one. You can stop if you are satisfied. Okay, okay, let me keep the last one, or anyone if you are satisfied. I just like missed while stopping. Yeah, those will not do much matter, but I just wanted. Okay, so let me keep the last one. I can remove it and remove it. Okay, so I was moving in your positive direction. You can see the velocity was positive always. Yeah, so again, see your region of interest. Okay, when it was slowing down, so this is the velocity that you gave. So the region of interest will start from here. Okay, and then to from here. When you started pushing the IOLab is from here, and when you like actual, it started from here. Okay, you stopped pushing the IOLab, you started pushing from here, and you start pushing from here. So the region of interest while doing the analysis will start from here to this point. Okay, so you may zoom it if you want. Okay, yeah, or you can leave it like that also, it's up to you. Okay, so this is where you started to push, but we left it here, and the reason IOLab was slowing down is starting from here up to this point. At this axial point where it started slow and it went to zero, where we catch it. Yeah, rate of change of velocity. So you can analyze the sign of the acceleration. Okay, I don't know if it is here or in the next slide, but okay, you can go ahead, put your times in. Okay, where you started to pushing, so something like that, where you start pushing, you release at it here. Yeah, the reason where we're not pushing, you are not pushing the IOLab, so that's the reason. Yeah, so IOLab was moving by itself from here to the kind of this region. Okay, the at this point the IOLab came to rest, so that's why we caught it. So velocity went to zero down. Yeah, describe how you identify these points of the motion, so you can explain how you identify. Okay. Okay, since this is important, this will be important part for the analysis in future. I'm just giving you. Okay, so this is where, like, when it started, velocity was zero in the beginning. When you started to push, it will get some velocity. Yeah, so you will keep on pushing. Like when you keep on pushing, the velocity increases up to a certain time. Yeah, and that's when the velocity becomes maximum. Means that's when you have released it from hand. Okay, the maximum. And after you release it from hand, there is no external force. Yeah, so it is being pulled back down. So that's why its velocity start to decrease. And when you stop, that's like, this is the reason where IOLab was not being pushed by anything. Yeah, so this is the reason where you push the IOLab. You started pushing, you left it, and then this was the slowing down process actually. Okay, so be careful of those moments, so you can explain it that here also. Okay, in slide 20, describe the shape of your velocity and actually with your prediction. So did we predict the velocity while slowing down? Rate slowing down means it is going, the rate of change of velocity is going to decrease. Yeah, constant decline. So did you predict like this? And as this is the area of interest, okay, this will be the area of interest for this one. So it's kind of constant. So did you predict like this, velocity and acceleration? Okay, from your graphs, what is the sign of the acceleration during the time interval when the IOLab was slowing down? So that's the time interval where it was slowing down from maximum velocity to zero. Yeah, so see the sign of the acceleration. How can you tell the sign of the acceleration from a velocity time of graph? Yeah, so for the, it has positive slope, negative slope. Okay, or rate of change of velocity. So based on the velocity graph, your answer. Okay, while moving in positive direction, if the slope is negative, or if it is negative, or while moving in positive direction, if the slope is positive, it is positive. So you can go ahead and make your analysis. Okay. Okay, next slide. So how can you tell the sign of the acceleration from acceleration time graph? Yeah, so you can basically look and just say, you can answer in your own notes, is the sign of the acceleration, which indicates the direction. Okay, sign what you predicted. How does the slowing down while moving in the positive direction result in the sign of the acceleration? And remember that acceleration is the rate of change of velocity with respect to time. Look at how the velocity is changing. Okay, how does slowing down while moving in the positive direction result in the sign of direction? So while slowing down in positive direction results negative sign. Okay, so you can go ahead, make your analysis, answer the questions, and click on save and go next. Okay, region of interest, slowing down is this graph. Okay, so this will be from here to here only, kind of. Okay, straight line. You can get back if you do like that, or you can click on auto scale. Let's see. Okay, we can get it back like this. From here to here. Yeah, so if you miss also, that's okay. There are ways to do get it back. Okay, pause record. Okay, for the sign of the acceleration, whether we will look at whether it is above our time axis or below our time axis. Yeah, so, and that can decide whether it's positive or negative. Okay, like we did last time, representing with arrows. Okay, so we have to represent that different time frame. What, so we are moving in positive direction. Yeah, so velocity, we are slowing down, so that means it will be higher. So higher length arrows moving in positive direction means represented arrows at 4 times. Okay, 4 time intervals. They want you to represent here. So moving in positive direction, velocity is positive. Yeah, so, and how do you define the acceleration? Is the rate of change of velocity. Yeah, so we are giving delta phi. Slowing down, T4 will have less velocity, T3 will have higher velocity. Yeah, T4 minus T3. So delta 4 minus V4 minus V3. So we need to see V4. Yeah, we are not going plus V3 because we are seeing delta V. So V4 minus V3. Okay, so you can see minus V3 means going to left. Yeah, V4 is towards the positive direction, and the rate of change is, that is what defines the sign of the acceleration. Yeah, so you may go ahead, write your answers. Okay, so if we are moving to positive direction, use arrow towards the right. If you are moving in negative direction, use arrow towards the right, sorry, left. For negative direction, towards left for velocity. Okay, so right now we are moving to our right, velocity is positive, so I think we'll need towards right only, but be careful about the magnitude, the length of the arrow. Okay, you may go ahead, do write your answers and click on save and go next. Okay, don't forget that. Okay, in the next slide, we are going to predict a general rule, like we are going to see a general rule based on what we have done. Okay, so this is not a general rule. Okay, I have just written same. So speeding up in a direction of motion. Okay, so whether it's positive or negative, result in the same or different sign of acceleration as direction of motion. So from the experiment that we have done, we are doing it in a positive direction. Yeah, while we speed it up in a positive direction, what's the sign of acceleration? Positive or negative. So if we do it in a direction of motion, will it result in a same sign of the acceleration or different sign of the acceleration? So you have to give a general rule. While slowing down in any direction, okay, in positive or negative direction, will it result in the same sign of the acceleration or different sign of the acceleration as the direction of motion? Okay, we know for velocity, if it is in velocity will have same sign as the direction of motion. Yeah, if it is moving in positive direction, sign of velocity is positive. If we are moving in negative direction, sign of velocity is negative. Okay, so if we are speeding up in a positive direction, will we have a positive sign of the acceleration or negative sign of the acceleration? So based on that, write your general result. Okay, so the line will be look similar, either you have to remove same or different. Okay, so speeding up in a particular direction of motion results in the same or different, so you have to write based on what we have seen so far. For we have done it for positive only, but for based on that, write the general rule. Okay, you have to either remove same or different, either remove same or different. Okay, go ahead and write the general rule and click save and go next. You have to remove either same or different. Okay, be careful of that. This is not a general rule what I have given. Okay, now we are changing the direction of speeding up. Yeah, speeding up while moving in the negative direction. In the last one, we were like making positive axis towards the bottom. Now we are making positive axis towards the up. Okay, we will be speeding up in negative direction. So the kind of double wheel to single wheel. Yeah, so positive direction is upward. We will be speeding up in the negative direction. Okay, so we have to make the prediction. So I have already indicated the velocity is speeding up. Yeah, so velocity will have the same sign of the direction of the motion. If you are in negative direction, velocity sign of the velocity will be negative. Okay, then it is speeding up. So based on that, go ahead, make your prediction. Okay, either, and for the acceleration, the rate of change of velocity is acceleration. So make your prediction for velocity and the acceleration graph. Okay, and then click on save and go next after that. Okay, now we are going to do the real experiment. Yeah, speeding up in negative direction. That's our ramp, and the remote is, again we have to turn it on. Yeah, so we have to speed up in negative direction, so we have to make this as a negative direction. Okay, so again, so double wheel to single wheel is a positive direction, so this is the one with the positive direction. Yeah, so we'll be pointing it up, so, and this is the negative direction, so that's positive, that's negative. We'll be moving, speeding up in negative direction. Okay, so we'll keep it here. Okay, let me see. The graph we already have it here is for slowing down. Yeah, we did it for slowing down in positive direction. Okay, so let's record it, and then we can already catch it. Okay, before it hits. Okay, I think that was good. You can do it again if you want, but I think that's fine for me. Okay, you may do it again. So yeah, I hope you know which one was our graph. So I can do it again actually. Okay, let me do it again. Okay, this time I have decreased the height of the ramp. It was higher. Let me spinning up, so I can add on. I can just keep it here. I'll record it. Okay, and then, is that good? It's also kind of good. Okay, let me do the last one. Okay. No, I can keep the first one also, that's fine. Okay. Okay, so that's the nature of the graph that we'll get. Okay, so let me remove the last one. Okay, so this is the graph that we got here. So this is when I left, then it is speeding up. As I said, the direction, the sign of the velocity is the direction of sign of the direction of the motion. Moving in negative direction, I always had negative sign of velocity. Yeah, so rate of change of velocity. So, and then you can see this graph. Okay, this is the one. So this is the like kind of ball. Okay, region of interest starts from here, kind of here, so here to here. Okay, slowly speeding up in negative direction. You may go ahead, click save and go next. Okay, so was moving, how was your velocity graph? That IOLab was moving in negative direction, so you have to explain. So it is constant. Okay, it is increasing with constant rate, decreasing with constant rate, having negative slope, positive slope. You may write down. During the time the acceleration was positive, negative, or zero. So the IOLab was moving down. You may write it down. Okay, did they agree with your prediction? Compare the acceleration you observed on your graphs from activity 2.1 that was persistently displayed 2.1. So I think that was the one for 2. Oh, sorry, that was the one for 2.1. Yeah, you are slowing down. So this is kind of, if you say, it's kind of same. Yeah, so that was for 2.1. Yeah, slowing down in positive direction and speeding up in negative, slowing down in positive direction, speeding up in negative direction. So they want you to compare, explain how speeding up while moving in the negative direction is of the sign of acceleration. Does they agree with your prediction? Okay, so you may go ahead saying the results, region of interest. And so the activity 2.1 means they want to compare the sign of the acceleration here, this one. Okay, it's kind of same. Yeah, is it sign or just they want? Okay, you can go ahead, compare based on your graph, write the answer, and then click save and go next. Okay. Okay, in the next slide is speeding up while moving in the negative direction. When an object is speeding up, what must be the direction of the acceleration relative to the direction of the object's velocity? So while moving in negative direction, object's velocity is negative. Yeah. So, and what happened to the direction of the acceleration? Is it negative or positive? So is it same or opposite? I think it is going to our general rule. When we move in a direction, speeding up in a direction, does it result in the same sign of the acceleration or different sign? So we are moving in negative direction, we're speeding up in a negative direction. Did it happen to be the same sign of the acceleration as the velocity? So you may go ahead and answer this one. Okay, and click save and go next after you answer. Okay, reminding, the question is asking, when you speed up in what no direction, when you speed up in a direction of velocity, okay, object velocity. So we are speeding up in negative direction. Yeah, direction of velocity means we are speeding up in negative direction. Does it result in the same or opposite sign? So you can answer based on that. Okay. Again, we have to represent velocity with arrows. Yeah, we are speeding up in a negative direction. So I've already been telling, sign of the velocity is same as the direction of motion. So if you are moving in negative direction, sign of velocity is negative. Arrows will be pointing left for the negative, yeah, right for the positive, left for the negative. So magnitude is arrows with higher magnitude means higher length, sorry, higher length of the arrows. Yeah, higher magnitude of vector means higher length of the arrows. So speeding up means we will have higher magnitude when the time is farther than in the beginning. Yeah, so based on those, make your arrows directions like you did for the previous one. Okay, this question delta v again. Yeah, so we are having a negative velocity, v4 is negative, and best, okay, v4 minus v3. So v4 is also negative, v3 is also negative. So we are speeding up in a negative direction. Okay, so v4 minus v3. Okay, so actually minus based on that one, so we have to decide whether it's positive or negative. So if you see our final velocity is v4, yeah, v4 is pointing towards this side. Okay, negative direction. Yeah, v4 is negative, minus v3. So if we make it plus v3, it's going to be this side, negative again. So v4 minus v3, delta V is given. Okay, so you may go, or you can do the analysis by yourself. Okay, before that has to be pointing left. Okay, minus V3. V3 still has to be pointing left because we are moving in negative direction. Yeah, but this minus sign will reverse the direction. V3 was this side, but minus will make this one. And if you do the delta V thing, you will result in this one. Okay, you may go ahead, write your answers, click 7, go next. Okay, time for the general rule. Okay, so let's say the general rule. If you are speeding up in a positive direction, it will result in a positive sign of the acceleration. That's what we have seen now. If you are speeding up in a negative direction, okay, I think I got that. It will result in the negative sign of the acceleration. Let me show you again. Okay, I just did auto scale and got those back. Okay, so speeding up in a negative direction. Okay, I think I'm clicking here. That's why they are speeding up in a negative direction resulted in negative sign of the acceleration. So speeding up in a particular direction will result in the same sign of the acceleration as the direction of motion. Speeding up in a direction of motion results in the same sign of the acceleration as direction of motion. Slowing down in a particular direction results in opposite sign of the acceleration to the direction of motion. Okay, so speeding up gives the same sign as direction of motion for the acceleration. Slowing down gives opposite sign for the acceleration compared to that of direction of motion. So I think that would be a general rule. Based on that, go ahead, explain your answers. Okay, write your answers. Okay, based on our general rule, we have been asked to answer this question. Okay, well, we have not done one combination, which is slowing down in a negative direction. Yeah, we did speeding up in a positive direction, slowing down in a positive direction, speeding up in a negative direction. So based on, we have not done speeding up in a, no, slowing down in a negative direction. Okay, so what our general rule says, if we are slowing down in any direction, the sign of the acceleration will be opposite to that of direction. Yeah, slowing down in any direction, general rule, slowing down in any direction will result in opposite sign of the acceleration to that of the direction we are moving. Okay, so based on that, slowing down in a negative direction, so acceleration slowing negative direction, slowing down acceleration has to be positive. Okay, that's based on general rule. So go ahead, answer your questions, click save and go. In the next slide, you may just I think that this is arrow thing. So we have been doing this, represent your velocity at different time with the arrow, slowing down in negative direction. So slowing magnitude will be slower when you go further with the time. Yeah, and negative moving in direction, velocity is going towards left. So based on that, make your arrow. Okay, so after that, slowing down in negative direction. So before slowing down, yeah, before will be shorter. B3 would have been that side longer, before minus B3, slowing down in negative direction. Okay, go ahead, answer the questions and click next. Okay, reversing direction means we'll move in one direction, stop, and then come back to other direction. Yeah, so we have to make a prediction for this one. You give the so velocity moving up the IO ramp. We are moving in positive direction, I think so. Let's see, positive incline ramp, positive direction. So moving up is a positive direction. Okay, so it moves up while moving up in the IO ramp. So we have moving in a positive direction. So we have already said, yeah, which is make your prediction based on what we did. Velocity is greater than 0 moving. So velocity will have the same sign where we are, which direction we are moving in. Okay, we are moving in positive direction, it's going to be a positive sign. And now we have a general rule, is speeding up in same direction. Speeding up in a direction gives the same sign of the acceleration. Slowing down in a direction gives the opposite sign to that of the acceleration to that of the direction. Yeah, so we are moving up the ramp, means we are going to slow down. Slowing down in a positive direction, slowing down should give a different direction. So based on the prediction, it has to be negative. So based on these analysis, go ahead. Yeah, so at the turning point, it has to stop. Yeah, and then go ahead, make your assumption and then prediction, and then we'll do the real experiment. Okay. Okay, so for the reversing direction, so we are moving in the beginning, we are moving, slowing down as the IOLab move in the ramp. We are slowing down in positive direction in the beginning. Okay, moving up the IOLab, then we'll come to the rest, and then will move speed up in the negative direction. So for velocity, it will be have the same sign as the direction of the motion. So make a prediction. Okay, we will be slowing down in the beginning, so velocity has to be positive and going down, and then continue to the negative side and speeding up. Okay, so make a prediction and then move to the next side. In the next slide, so it is about the acceleration. Okay, so acceleration, we have the general rule based on our general rule for three instances of time. Yeah, acceleration for this time for slowing down as the IOLab moves up ramp in the positive direction. Up is the positive direction, we are slowing down in positive direction, we come to rest and we reverse the direction. Okay, confusion could be at the turning point. So at the turning point, velocity might be zero, but acceleration is the rate of change of velocity. Okay, so acceleration might not be zero. So based on the general rule, you may form the sign of the acceleration and see which one of them will be the correct one. Okay, predict your, and then click save and go next after making the prediction. Okay, now time to do the real experiment. Again, the IOLab we have been inactive for some time, so IOLab has got turned off. Turning it in again, yeah. So as it has been said, we keep it down here. Positive y-axis is while slowing down, yeah, in the beginning. So it has to be pointing up. Yeah, this is positive y-axis side, double wheel towards the single wheel, that's positive y-axis. Okay, so we have to make this as positive y-axis, this side positive y-axis, down is negative y-axis. Okay, so positive moving, slowing down towards the positive y-axis, it will stop and then return back. Okay, so we have to record the whole thing, and this is reversing direction, so they will be moving in a positive direction, we will stopping and returning back, and let's see what we predicted is right or not. Okay, we may repeat the experiment, but okay, record it. So let me do it a push, so I can let it reverse and catch it. Okay, I think I'm satisfied, but you can do the second one also. Okay, add on, record. So let me give it a push, stop. Okay, that was not good, but still I got some result. Okay, the last one. Okay, add on, record. So let me give it a push and we come back and then I stop. Okay, I think everything was good. Let me stick with the first one. That's okay. We moved in a positive direction, we slowed down in a positive direction moving up the ramp. Okay, so make sure while doing the experiment this ball is towards up. Okay, so double wheel towards the single wheel is positive direction. Okay, then we stopped and then it returned back to the negative direction, slowing down in positive direction, stopping and speeding up in negative direction. That's what we actually, it is the combine of the two labs what we did previously. Okay, okay, let me stay with the first one, you can do it on here. Okay, so what is the area of interest? That is when I started to give push, that is not the one. Okay, so this is slowing down in positive direction. Yeah, then the velocity is zero, maximum velocity is started to slow down, it becomes zero, that's the turning point, and then it's speeding up in negative direction. Okay, up to this point only, that's where it stops. So the reason the IOLab was moving, slowing down by itself from here to here only. Okay, so you may go ahead, click save and go next. At what time you start to push the IOLab? So we started to push from here. Yeah, that was not the slowing down thing started, so then we left it at here. So pushing that here, so it went to the maximum velocity, we left it like start pushing from here. At what time did the IOLab reach its highest point? It has been means it has to reverse the direction, highest point it is stopped, so that has to be zero, velocity has to be zero, somewhere around here. At what time did you stop the IOLab with your hands? Means with your it was speeding up and then again came back, kind of return, it has to return from zero. Yeah, so you stop with your hand means at the bottom of the IOLab, so kind of here, then it will go back to zero. So this is the kind of point. Okay, so go ahead, write your points as I have explained. So slowing, reversing direction was from this point to this one, other things was pushing and stopping. So go ahead, write your answers, click save and go next. Okay, okay, after that in slide 36, reversing direction, the dial is stop at its turning point. So was the velocity zero? So based on that we can answer this. Yeah, did this agree with your restriction? Did it spend much time at the turning time before it started to back down? So how long was the velocity zero? It's kind of asking that. Okay, so did it spend longer time or just quick time? Okay, go ahead, answer the questions in your own words and click save and go next. Okay, in the next slide, we have to make, I think, do the analysis seeing the graph, yeah. So according to your acceleration graph is the acceleration at the instant of IOLab. It says its turning point, whether it's positive. So that is our turning point, yeah, when the velocity is zero, when it stops. So is it positive, negative, or zero? So you can go ahead and answer. Is excellently significantly different from that during the rest of the motion. So is it different here? So it seems constant, yeah. Does this agree with your prediction? Explain the observed sign of the acceleration at turning point. So you go ahead, explain. Based on acceleration is the rate of change of velocity, as I've already told you. So explain your sign of the acceleration at turning point. Okay, saying the rate of change. So you can take 1 point at here while being in the positive side, 1 point at here. Okay, and if you do the calculation rate of change thing, you from 1 point in here, one from here. So you may get do the expression like that. Okay, explain in your own notes, answer the questions, and click save and go next. Okay, in the next slide, we have been asked to explain the sign of the acceleration during push. Okay, and during the stop. So that was push means when we are pushing the IOLab. Okay, I think this was the reason. So is it positive or negative for that reason? Okay, it seems to be positive. And what is the sign of the acceleration when we stop? So we stopped at here. Yeah, so this is kind of here. So it seems to be positive again. So we have to. So for the reason, it's kind of speeding up in a positive direction, yeah, because we are giving a velocity from zero to start up and speeding up in a positive direction. So from the general rule, we may explain like that also. We need to have a positive direction, and while stopping means you see the velocity is going outside. This is going, yes, the magnitude is going down, yeah, slowing down in negative. So slowing down will result in the opposite sign. Slowing down in negative should give positive sign, yeah. So I was just explaining the reason. Okay, this is the region of the push, this is the region of the stop. Okay, and this is like our regular reversing direction, slowing down in a positive direction, speeding up in a negative direction. But that was kind of speeding up in a positive direction for the push, slowing down in a negative direction for the stop. So based on that, you may answer your notes here, okay, in your own notes, and click save and go next after you answer. Okay, in the next slide, it is like throwing up a ball in the air. It is similar to what we just did. Okay, so you throw up a ball into the air, it moves upward, it says height comes, and then it moves back. Assume the upward is positive direction, indicate whether the velocity is positive, zero, or negative. So it is like what we just did. Okay, if you think moving up is a positive direction, so when you throw in the beginning, it would have high velocity in the beginning. Velocity keeps on decreasing until it reaches the top. Yeah, kind of slowing down in a positive direction, and then it reaches the turning point, it stops, and then it comes back again. So the moving downward is negative direction, is speeding up in a negative direction, like for what we just did. Okay, so moving up after release. So moving up is a positive direction, they have said. So the velocity should have the same sign. Yeah. Yeah. So we are slowing down as we are moving up. So slowing down in any direction will result in the opposite sign of the acceleration. Go ahead and answer based on that. At the highest point, we already know the way it stops. For the acceleration, we did it from the graph. So you may go ahead and refer that. Go ahead and answer these questions. Okay. So it is kind of what we just did, similar thing. And then you can go click save and go next after you write all the answers. Okay, make sure you write all the answers before saving and going next. Okay, in the next one we are trying to create motion similar to the incline ramp by using a hanging mass. Okay, so you can see positive y direction is towards that side. Yeah, hanging mass is this side, so I think we'll give a push from that side, slowing down in a positive direction as it is really pulling, yeah, and then it comes stops somewhere here, comes back speeding up in a negative direction. So best again for that one. So select the below that discuss velocity for the motion after release, slowing down as the IOLabs move in a positive direction, slow down in a positive direction. Velocity, whether it's positive or negative. If you are moving in a positive direction, velocity has to be positive or negative. Okay, go ahead. When it stops, velocity has to be when then after you to return back, yeah, and then it is kind of moving speeding up in a negative direction. Moving in a negative direction, velocity, sign of velocity. So based on that, make your prediction. And so I'll say acceleration, use your general rules, slowing down, turning point, moving up, speeding up. Okay, make the predictions, and then you may click save and go next after making the predictions. Okay, for creating the motion, similar motion like we did for slowing IOLab moving up the ramp, going to rest and turning back, we'll use a hanging mass, okay, around 6 gram. So I've already clicked save and go next. So if you see here, so we have to use a hanging mass around 60 gram. Yeah, with this length I have used a general string, and I have used a water bottle. If you can see here, for 60 gram I just took around water bottle, and then I have tied it in the IOLab. Yeah, the water bottle is here, okay, with the string. So it's better to have the round surface here, okay, round one, but I have this one, so just take it one. I'm just going to hang it down here. I have this string here, okay. If you have round surface, you will get the little bit. You might not see the string, but the string is right here, okay. And I am using the string, so we will be moving towards the positive direction. So this is the positive side. Eyeball is here, yeah. So that's positive side, positive side. Double wheel towards the single wheel. Don't confuse with the directions one in your IOLab device itself, okay. So we'll be giving a push that will be slowing, going that side. So since the bottle is pulling it back, so it's going to be slowing down in a positive direction. It will reach at some point, it is stops, that's a turning point, and then it will come back speeding up in a negative direction. So it is kind of same thing what we did last time, okay. So we are just using hanging first for now, so let's do it. So let's start from here, okay. So we can click on record. Let me give a quick push, and then I'll stop when it comes back, okay. So if you are not satisfied, you may do it again, okay. You may use other, like for you may use IOLab box for the weight also, okay. So 0.6 gram is around 0.6 Newton. You can weight with IOLab also using the force sensor. Add run. Let me record it. Let me just push it. That was kind of slow, but okay, I can do it for longer reason, okay. Add run. Record. Give it a push, it goes back, and catch it when it comes back, okay. Okay, so this kind of curve is because I'm using, it's not a smooth, yeah. So if it was smooth like a pulley, it could have been a different result. It's better to use the smooth one. Okay, let me give it a last try. Add run. I'll record. Just create it. Just trying to do it for a longer time. Okay, nothing more. But the first one was also okay. So you can take it as a straight line, okay. If you the surface very smooth, so see your nature with the previous one. Take it as a kind of constant thing, okay. Let me see the last one. Record. And just give a smooth moves. So does that work? I think it's similar kind of. Okay. So that's it. I have used water bottle as the 60 gram. Okay. So what we did, that was when I gave the push to the water bottle. Yeah, when I released it, so it is slowing down to a positive direction. Okay, then it stopped and it's spreading up towards the negative direction. So nature of the graph, if you see, it's similar like what we had for the one when you use the ramp. Okay, you can save and go next. Okay, so at what time you started pushing the IOLab. Okay, this was the one. Then what do we push in? So I left it at here and the maximum velocity here. I'll have reached the furthest point to the right. So that means when it was turning point, yeah. So it is a kind of velocity 0. But at what time do you strip the IOLab with your hands means? So we just stop it here and then went back to 0. That's the point where you started. Okay. Again, so you would have got a straight kind of straight line if the surface like table was round. Yeah, I had a, I mean, so, okay, so this thing was not round, and the little string also I used a general string. Okay, so it could, if it was like a pulley or thing, then it could have been more straight, smoother line. Okay. Okay, now we have to describe our graphs. Yeah, did it agree with the predictions? So predictions were similar to the graph that we had while moving the ramp. We're moving IOLab in the ramp, slowing down in positive direction, turning point, and speeding up in negative direction. Would you describe the motion as having a constant velocity or constant acceleration? So velocity is kind of like with a constant slope is there, yeah. In positive direction is slowing down, in negative direction is speeding up. Acceleration is kind of constant. So you may go ahead, write your answer here, and then click save and go next. Okay, in the next one, what was the sign of the acceleration when you move the IOLab to the right? Right means positive direction, yeah, moving towards the positive direction. So that was slowing down in positive direction. So move to the right. What is your sign of acceleration? Whatever the left? When you're moving left means speeding up. When you're speeding up, what is your sign of acceleration? So we have to explain based on the general rule. Yeah, if we are speeding up in a certain direction, we will have same sign of the acceleration as of the direction, and slowing down in any direction, sign of the acceleration will be opposite to that of the direction. Okay, so we are slowing down in positive direction, sign has to be negative. We are speeding up, when we speeding up in negative direction, sign has to be some, so it was always negative. Yeah, so you may go ahead, explain it here, and then let and go next. Okay, that brings us to our second last slide. What was the sign of the acceleration lab when it was furthest point to the right, means when at the turning point? You can see here, explain this value of acceleration again based on rate of change of velocity. You can explain your answers. Are your graphs similar to any set of the graphs in investigation 2? Which ones? Explain why. So set of the graphs, yeah. So you can see slowing down in positive direction and speeding up in negative direction. Okay, so you can explain based on those. Actually, it was for reversing direction also, yeah. So investigation 2, so that might be asking for the group, or you can go ahead and search this investigation 2. It was sure for reversing direction, but yeah, I think that was for reversing direction. Go ahead, answer this and click save and go next. Okay. Okay, that concludes our lab. Yeah, you may save and go next. Okay. And then if you want to create the report into PDF format again, so you can write your name. Yeah, edit your name. Okay, write your name, and you can save, and then you can export to PDF. Yeah, so anyway, you can save and export to PDF. Better do it. Okay, it's any location you like. Okay, but me, if you want me to save, so, yeah, you can save it any location, and then green signal will come here. Okay, that's it. Do it. Thank you.